So today's topic is the simple harmonic motion. So in the previous video we talked about the naming like of the uh, of this topic, simple harmonic motion. So you can check that out. And today we'll go more deeper into it. So what is simple harmonic motion? In short form, it is called SHM. SHM. So it describes how things move when they oscillate. So so let's look at two things. So for instance, if there is a bob and it's the trajectory and this is the equilibrium, so the displacement we see, it's outwards of the equilibrium. But if you raise a pendulum up to this point and you leave this, so the force that will the bob will face, it's towards the equilibrium. So same here, like the force, like if the person was on in a swing, and the force he will obtain when he's at the maximum displacement is this side, so it's inwards, but the displacement is outwards of the equilibrium. So what we see is that it's a condition for SHM or simple harmonic motion, that is that we know that force is proportional to acceleration, so it's kind of equal. So the first condition for SHM is acceleration. For force you get acceleration. So as force is in opposite direction of the displacement, so the acceleration force acts in opposite direction. So this is the first condition. If you look at the second condition, what you will see is that if you increase the radius of the trajectory, or if you increase the displacement, so the force that you will get, it will be higher for the as you increased it. If you increase the height, there will be more gravitational energy. So what you will see is that the force you will come back with will be higher. So more the displacement, more the force. So we see that increasing the displacement, we also represent displacement with x. So increasing the x increases the force, which is equals to mass times acceleration. And if mass is constant, so if we focus into acceleration increases. So as displacement increases, the acceleration increases. So now if you get back to the definition of SHM or simple harmonic motion, what we see is that simple harmonic motion is a motion of an oscillation in which its acceleration is directly proportional to its displacement. So this is the first point, is directly proportional to displacement. And the other thing which I didn't write is that the the action is in opposite direction. So that's the second marking point. So what we come to say is that the acceleration, as it increases, so as you increase the acceleration, the displacement also increases. So we can say that acceleration is proportional to the displacement. So this was example 2. The condition 2, that they are proportional. So so example 2, we saw that acceleration is proportional to the displacement, and from equation 1, I mean not from equation, from the example 1, we see that they move in opposite direction. So there should be a minus here. And if you want to make it, equal, so you get a constant which is found out to be 2 pi f square. And we know that this is also omega. So our overall equation, we can say, we can bring the minus in front of omega. So we get equation which is acceleration is equal to omega minus omega square into displacement. So for today, we will leave it up to this. I will see you next class.